need for partition, because like every memory is not going to be used by only one process. Okay, it has to be used by many process. So we need to partition the memory so that we can allocate many process. Okay, so this is about fixed partitioning, where we partition the memory into fixed sizes. Okay, so the easiest and one of the simplest techniques can be used to load more than one processes in the main memory is called as fixed partitioning, or we call it as contiguous memory location. Okay, contiguous meaning we have to allocate in a sequence manner. Okay, so in this technique, what we're going to do is we're going to divide this main memory into partition of equal or different sizes. Okay, so all we have to know is that in this fixed partitioning type, we are going to partition the memory in a fixed manner before starting the processing of the process. Okay, so we are going to partition it may be on same or equal or different sizes. So the operating system will use the first partition, while the other partition can be used by the other user processes. So one point to be noted here is that you have to assign the process in a contiguous way. That is, we have to assign the memory in a sequence manner of the uh, memory location. Okay, so then in this fixed partitioning, uh, the partitions cannot be overlapped, and a process must be contiguously present in a partition for the execution. So even when we have like uh, two free space, if they are not in a sequence, then we cannot use it for a process. Okay, so the uh, the memory or the cell or the partition available should be in the in the contiguous or in a sequence, so that the process can use the memory. So when we are talking about this fixed partitioning, we have two types of cons. That is, one we call it as internal fragmentation, and another one we call it as external fragmentation. These are two terms you might be seeing before also. So when we say internal fragmentation, we refer fragmentation inside the partition. Okay, so and when we say external fragmentation, we refer wastage of our wastage of our location or the storage for the overall memory. Okay, so when we're talking about this internal storage, okay, internal fragmentation, so let's just see it here. If the size of the process is less than the total size of a partition, then some size of the partition get wasted and remain unused. Okay, so this wastage of memory is called as internal fragmentation. So as we mentioned before, that when we are talking about this fixed partitioning, before starting the processing of the process, we have to fix the size of the partition. So if we partition the storage as for example for 4 MB, and if we use only 3 MB, then there is wastage of 1 MB in that partition, right? So if we have a partition with 4 MB, and if we use only 3 MB of that memory, then we have one MB of memory being wasted. So this scenario is what we call as internal fragmentation. Okay, and then we have this total unused for this external fragmentation. Total unused space of various partition cannot be used to load the processes, even though there is a space available, because the spaces are not in a contiguous or in a sequence form. So I okay, let me go to the diagram first and we'll come over here. Okay, okay, just look at this diagram. So we have some four process with is requiring 3 MB of memory, whereas we partition this memory into 4 MB. It's right. So if we partition it with 4 MB while the process require only 3 MB, what is being wasted? So 1 MB, 1 MB for the second one, 1 MB for the third one, 1 MB for the fourth one as well. So in each of the partition, there is a wastage of 1 MB, right? So when we are talking about this, let's say for the first partition, so the problem here is we call it as internal fragmentation. So in the same partition, there is a wastage of memory. So we call this as internal fragmentation. Second, also we have internal fragmentation as there is 1 MB of memory being wasted. Even for the third one, even for the fourth one also. Okay. So there is a wastage of memory. So when the wastage is inside the same partition or inside the same block, we call it as internal fragmentation. Coming to the external fragmentation. So when we see overall, so we know that we have 4 units of like 4 MB of free space. Okay, so we have one for the first one and 2 for the second one, then 3 and 4. So totally we have 4 MB of unit being wasted which cannot be used. Okay, so this, even though there are 4 MB of storage that are available, we cannot use it to allocate a new process, let's say P5, which require 4 MB. Even though the memory has the capacity of this 4 MB, but since they are not in a sequence manner or in a contiguous manner, we cannot allocate it to the new process P5. Okay, so this problem is what it refers to external fragmentation. Okay, so this is what your internal fragmentation and external fragmentation refers to. Okay, so the problem that may associated with this fixed partitioning is internal fragmentation as well as external fragmentation. Then the next problem is limitation on the number on the size of the process. So if the process size is larger than the size of maximum size partition, then the process cannot be loaded into the memory. So therefore a limitation can be imposed on the process size. That so if the process size happens to be more than the size of our partition, then we cannot allocate the process to the system. And so by degree of multi-programming, we simply mean that maximum number of processes that can be loaded into the memory at the same time. Okay. So like so the number of like many processes that can be loaded at the same time may be less when we use this fixed partitioning. Okay. So these are the few problems that may be associated with fixed partitioning. Okay. So all you have to understand from this fixed partitioning is that we divide the whole memory into fixed partition before, okay, before the process has been loaded, and once this is being fixed, we cannot change the size of this partition. Okay, and here the main point is there may be internal fragmentation, that is internal wastage of memory inside the partition, and there may be external fragmentation. Okay, there may be some unused space, but it cannot be used for another process. Okay, so coming to next type of partitioning. Yes. Dynamic. So then we have another type of partitioning, which we call it as dynamic partitioning. Okay. So in fixed partitioning, we know that we define the partition before the process has been allocated and it has been once fixed, we cannot change it. So to overcome some problem on fixed partitioning, we can use this dynamic partitioning. Okay. So in dynamic partitioning, as the name suggests, the partition is being like dynamic. It is not fixed. So in this dynamic partitioning, the partition can be done as per the process requirement. Okay. So here, so your dynamic partitioning is try to overcome the problem caused by the fixed partitioning. So the partition size is not declared initially. Okay. So it is declared at the time of process loading. So as usual, the first partition will be reserved for the operating system. Then the remaining space is being divided into parts. So here, in case of fixed partitioning, we fix the partition beforehand. Here we have to partition as per the process. So here is the difference. So the size of each partition will be equal to the size of the process. So and the size of the partition can be varied according to the nature of the process. So when we use this technique of giving the partition in a dynamic manner, there will be no case of internal fragmentation. So we just learned that internal fragmentation is wastage of memory in the partition. And if we do the partition dynamically as per the process requirement, then there will be no internal fragmentation. So in this dynamic partitioning, there will be no internal fragmentation. So let's see this diagram. So here, if you see here, we have for process, that is process 1 to 4, one require 5 MB of memory, two process 2 require 2 MB of memory, and process 3 require 3 MB, and process 4 MB. So if you look here, all these 4 process require different memory size. Okay. And if you look over here in the partition also, if you look, the first one is 5 MB, the second one is 2 MB, the third one is 3 MB, and the fourth one is 4 MB. So the partition has been done according to the process, and there is no case of internal fragmentation here over here. So this is how your dynamic partitioning works. But here we have learned that there is no case of internal fragmentation. But the next question is whether there will be external fragmentation. Okay. So external fragmentation may also be there in dynamic partitioning. Okay. So in case if like we have some free memory, and if they are not in contiguous location, then and if a new process that requires more memory than in one partition, even in that case also external fragmentation may be occur. So let's see. So in dynamic partitioning, your process size is equal to the partition size. Okay. So the advantage of dynamic partitioning over this fixed partitioning is, the first one is, as we learned, that there will be no internal fragmentation. So given the fact that the partition in dynamic partitioning are created according to the need of the process, so there will be no internal fragmentation. and there will be no limitation on the size of the process. So in case of fixed partitioning, if the fixed size partition is 4 MB and the process requires 5 MB, then that process cannot be fit into the storage. But here in this dynamic partitioning, as the partition is dynamic, we can allocate different types of processes sizes. Okay. Then the degree of this multi-programming is also dynamic. Okay. So here we have no internal fragmentation, so there are chances of more number of processes that can be allocated in the memory. So the next question that we were talking was external fragmentation. So even in dynamic partitioning, there can be external fragmentation as well. Okay. So absence of this internal fragmentation doesn't mean that there will be no external fragmentation. So let's see the scenario with, I think there must be a diagram. Okay. So this is the same diagram that we see before, where we have this for process. So if we have like the same scenario as before, and out of those 4 process, say we have completed the process for the process P1, that is this 5 MB is completed, that process P1 is completed, and process P3 is completed. Okay. So in that scenario, how much free space we have? We have 5 MB of free space over here. We have 3 MB of space over here. So totally we have 8 MB of storage being free in this memory location. Okay. So now the question is, if we have another process P5 that require 8 MB, okay, that require 8 MB of 8 MB of memory, whether it will be able to work out with this. So as we know that whenever we require, we give this location, it has to be in a sequence manner. Okay. So since the partition 1 and partition 3 are not in the contiguous manner or in a sequence, we cannot allocate this process P5 to this location. Okay. Even though the storage has the free memory of 8 MB and the process require 8 MB, we cannot allocate this process P5 which require 8 MB as the locations of the free memory are not in a contiguous manner. Okay. So considering this scenario, we learned that even when there is no internal fragmentation, there are chances of external fragmentation. So in this scenario, we find that external fragmentation is over here. So we have wastage of this 8 MB, and we cannot use the new process P5 which required 8 MB. Okay. So this is the explanation, right? So what we learn when we talk about this fixed partitioning and dynamic partitioning is that in fixed partitioning, the list of partition is met once and will never change. But in dynamic partitioning, the allocation and deallocation is very complex, since the partition sizes vary every time when it is assigned to a new process. So the OS has to keep track of all those partitions. So in fixed partitioning, There is no complex case of memory allocation. Everything is fixed and nothing can be changed. While in dynamic partitioning, your allocation of a partitioning or deallocation or of that partitioning has to be maintained by the OS. Okay. So, and it is a difficult task for the operating system to manage all this dynamic memory partitioning. Okay. So for today, we'll just discuss this topic. In the next topic, we'll continue. If you have any doubt of today's topic, you can raise the question about fixed partitioning and dynamic partitioning. If you have doubt, do raise. If you don't, you can just leave your attendance. So I assume everyone have no question. Okay, just leave your attendance and you can leave.